Hello, geometry. I wanted to talk about the last homework assignment as after you guys get it passed out. I'm going to talk about number 2. The first section, I had a lot of people get it wrong. Like you said that the central angle is the same as the arc, which is true if the directions said measure, but notice the directions say length. So I'm just going to go through problem 2 of this last homework, worksheet 7. The formula was take arc length over circumference and set it equal to the measure that most of you found, the measure of the arc over 360. So in problem 2, we have a radius of 5, a degree measure of 145, and I'm going to cross multiply and then divide by 360. The answer ends up being about 12.6. Similarly with problems 3 and 4, we're trying to find the arc length, so we're going to use a proportion with the radius and the angle measure that you found. If your paper says see me about these, that means a section that you have is either completely blank or a majority is wrong, and I need you to either come and see me during the morning, during the afternoon. We need to get you into tutoring. Quiz is coming up on Friday. So I'm going to switch to notes, so go ahead and get out your notes. We're doing chapter 11 circles, day 9. It's 11.5 part 2, so we're really going to concentrate on inscribed polygons and what happens when you have those. So first definition, inscribed is when all the vertices of a polygon lie on the circle. So an inscribed polygon is inside a circle. Now when you're circumscribed, you're a polygon that's you are around a certain object. So first off, this quadrilateral that you see here is inside the circle, so the polygon or the quadrilateral is inscribed, but this circle is on the outside, so the circle would be called circumscribed. So let me pop some things up. This is an inscribed triangle, this is an inscribed quadrilateral, but this circle's on the outside, and we could call it a circumscribed circle. So 2 theorems that we're going to be talking about. One of them, if a triangle is inscribed in a circle and is a right triangle, then the hypotenuse is the diameter of the circle. And the true is if you see a picture where the side of a triangle inscribed in a circle is a diameter, you can assume that the triangle is a right triangle. We're going to see problems that deal with this. First example. So what I see in this picture is a triangle inside a circle. Not only that, but I notice one of the sides is the diameter because it's running through the center. So I can assume this is a right triangle. Figure out which one of these is supposed to be the 90 degrees. Well, it's not this 50. It's actually going to be the angle that is not attached with the diameter. Or you could say it's the angle across from the diameter or opposite the diameter. So this x is 90. Then we're going to use angles in a triangle add up to 180. So with these polygons, you figure out which one's the 90 degree and then use the knowledge of angles in a triangle add up to 180. We're going to do this again. In the next example, we figure out which one's going to be, well, first off, notice how this triangle has a diameter as one of its sides. So the angle opposite of the diameter is going to be your 90 degrees. So that x is 90 degrees. And then angles in a triangle add up to 180. So we get an ending y degree of 30, x degree is 90. On to the next example. We notice we've got a triangle and one of the sides is the diameter. So I pick out the 90 degree angle, and the 90 degree angle should be this 15x. Now in this particular example, I'm going to have to set 15x equal to 90 and solve, since it's not just a plain x. So x is equal to 6. In the next case, I'm going to have these 3 add up to 180, but we already know this angle C is supposed to be the 90 degrees. So I'm going to have 90 plus 9y plus 9y. Get like terms together, and y is 5. Now we're going to switch to quadrilaterals being inscribed. So if you see a quadrilateral inside a circle, Its opposite angles are supplementary. And vice versa, if you see opposite angles of a quadrilateral that's inscribed in a circle, and you see that those opposite angles are supplementary, then the quadrilateral is inscribed in a circle. So if we see the following picture, opposite angles are going to be supplementary. I notice that the quadrilateral is inside a circle, opposite angles are supplementary. So z plus 80 should equal 180. And when I say z and 80 should equal, z plus 80 should equal 180. So that means z is 100. And like previous, but the opposite angles, y and 120, should add up to 180, giving us a measure of 60. Next example. So we notice I've got a quadrilateral inside a circle, so opposite angles are going to be supplementary. Starting with 4y and 64, I'm going to add those two to get 180. I subtract 64, and now I'll divide by 4. Y is 29. Similarly, I'll set 2z plus 64 has to be 180. I'll subtract by 64 and divide by 2. And we get z to be 58. Next example. I have a quadrilateral inside a circle. So opposite angles are congruent. This one's kind of hard to see. What is an opposite angle? 18y is opposite of 126. So I'll add those two together. Subtract by 126 and divide by 18. And we get y to be 3. Opposite angles, 18z and 72. It's not clear, but these guys are opposite angles. 72 plus 18z has to be 180. Subtract 72 and divide by 18. And your ending answer is 6. With this being done, in conclusion, going back to that previous example, so if you, we dealt with inside triangles or inscribed triangles, and if you see that one of the sides of the triangles goes through the diameter, that it's going to be a right triangle. And we also saw if you're an inside quadrilateral, inside a circle, opposite angles are going to add up to 180. You're ready for homework.